Hello, this is Sabbir Malli. The topic of our discussion in this video tutorial is method of undetermined coefficient. This is the third video on this topic. In this video, we will consider some other different type of forcing term. Our first example is what if the forcing term in our non-homogeneous differential equation involve sin x or cosine x. In this case, the very first solution we will consider will be of this form. So y of t, we have a cosine of t, the forcing term, the type of forcing term in exponential, b sine of t. The reason is that when we take the derivative of sine, we get cosine and it alternate from sine to cosine. So considering just b sine x as a particular solution will not work. So we have to include the cosine term as well. So this will be our assumption that this is the solution, and now we will try to determine the coefficient a and b. So first we will calculate the first derivative of this uh, solution. So this will be a negative a sine of t plus b cosine of t. And then we will calculate one more derivative of this. And this will be a minus a cosine of t and minus b sine of t. Let's assume this is equation number 1. Therefore, 1 implies minus a cosine of t minus b sine of t. That is the second derivative. Then minus 3 times y prime, which is a minus a sine of t plus b cosine of t, minus 4 times y, which is a cosine of t plus b sine of t. And this is equal to 2 sine of t. Therefore, this is equal to, now I will collect all the term which has a sine and cosine. So let's collect this term which has a cosine of t, that is a minus a, and then here is gonna be a minus 3b, and from here is a minus 4a, plus the term containing sine of t is minus b, minus minus plus 3a, and that's the minus 4b is equal to 2 sine of t. Now we will equate the coefficient. So this implies this is a minus 5a minus 3b is equal to 0 because there is no cosine term on this side. And the second equation will be this is a 3a minus 5b, and this is equal to 2 because the coefficient of sine is 2. Now we have two equations, minus 5a minus 3b is equal to 0, and then 3a minus 5b is equal to 0. So this is the two system of equations. We use the linear algebra to solve these two equations. To solve these two equations, first I will do is I multiply this equation by 3 and then multiply this equation by 5 and add them. So this will get to 0. So then we will have minus 9 and minus 25. B is equal to 10. Therefore, B is equal to 10 divided by 25 and 9 is 34 with a negative sign. Therefore, this is the negative 5 over 17. Now I plug back into the first equation and try to find the value of A. So to do that, I will have minus 5A minus plus 15 divided by 7B is equal to 0. Therefore, A is equal to 3 divided by 17. Sorry. Therefore, now we are ready to write down the solution because we have the values of A and B, and we will plug these values in our assumption, the solution we assume. So the particular solution of this differential equation is y of t is equal to 3 divided by 17 times cosine of t and minus 5 divided by 17 sine of t. So notice, even though the forcing term does not have cosine term, but the particular solution may have the cosine term in it. If the forcing term have sine plus cosine term, we still assume the particular solution y is equal to a cosine t plus b sine t. Here I have one quiz problem for you to practice. Please pause the video for 1 minute and work on this problem. So our next problem is when the forcing term has a polynomial function. So it could be just t square, it could be 1 plus t square, it could be just t, or it could be just constant also. Any type you have any polynomial function on the forcing term, the initial guess for the solution will be y of t is equal to a constant, b time t plus c time t square. So we will go to the degree of the forcing term. If the degree of the forcing term is a 3, I will add one more term in the particular solution. Now, as usual, we will calculate the first derivative of this function. I got a will become 0 plus b plus 2ct, and then I will calculate y double prime of t. This will be a 2c. Let's assume this is equation number 1. So 1 will imply 2c plus 4 times b plus 2c times t, and then plus, there is no y prime term in it. There is only a y term. So plus 4 times a plus bt plus ct square is equal to t square. So therefore, this implies 2c plus 4a. This is the coefficient, the constant term. Then you have plus 4bt plus 4c t square is equal to t square. Now let's equate the coefficient. So therefore 2c plus 4a is equal to 0, and then 4b is also equal to 0 because there is no other coefficient of t square on the other side, and therefore 4c is equal to 1. So this will give us c is equal to 1 over 4. The value of b is equal to 0, and the value of a come from the first equation. Since c is equal to 1 over 4, so 2 times 1 over 4 plus 4a is equal to 0. Therefore 4a is equal to minus 1 half. Therefore a is equal to minus 1 over 8. So now I am ready to write down the solution by plugging all these values into my solution. I assume so a is equal to minus 1 over 8, b is equal to 0, so there is no term with the t, and c is equal to 1 over 4 plus 1 over 4 t square. So this is our particular solution for this type of non-homogeneous differential equation which has a forcing term in t square. Now let's do one more example where basically we have the exponential function multiply to a polynomial function. So now we have multiplication of two different type of forcing term. In this case, basically we will assume the y of t, the solutions. We supposed to have e to the power t cosine of 2t term, and then we have coefficient a, plus we have b time e to the power t sine of 2t term. Because when you have cosine or sine, you both supposed to have both sine and cosine into your particular solution. Actually, I can write this as e to the power t as a cosine of 2t plus b sine of 2t. So now you can see there should be two constant in the solution because of the order. And when you have the trigonometric functions, you write a cosine of that function plus b sine of that angle, what we are in the forcing term. Now this will be a little bit more challenging problem. So to calculate the derivative, so let's calculate the derivative very carefully. Y prime of t will be e to the power t as it is cosine 2t plus b time sine 2t plus e to the power t, and this is a negative 2a sine 2t minus negative b, sorry, positive b cosine 2t. You can pull out e to the power t if you want to simplify, and then it will be, and also you can collect the term of the sine and cosine. So therefore a plus 2b cosine of 2t plus b minus 2a sine of 2t. It will a little bit help to calculate the one more derivative. Other than that, we just have to calculate the derivative. So now if we calculate y double prime of t, I get e to the power t and then a plus 2b cosine of 2t plus b minus 2a sine of 2t. Therefore, this is equal to e to the power, next term is e plus e to the power t, and now the derivative of this term. So it's gonna be a negative sign came out, and then you're gonna have 2 also. So 2 times a plus 2b, and this term becomes sine of 2t, and then this term become cosine of 2t. So this is a plus, 2 came out, b minus 2a cosine of 2t. Okay, let me a little bit make a space here. Okay, next I'm gonna pull out e to the power t and combine the term which have cosine. So cosine term you can see here we have a plus 2b plus 2b minus 4a, and it has a cosine 2t plus, then you are merging this term to that term, which is a b minus 2a minus 2a minus 2b, which have sine of 2t. One more step, e to the power t. Let's see, this become 4 and that become 3. So minus 3a plus 4b has cosine of 2t, and plus this become 4 and that become 1. So minus 4a minus b, yes, sine of 2t. Now let's plug everything into this equation, and then hopefully we will be able to equate the coefficient next. So y prime is e to the power t, and this minus 3a plus 4b as cosine of 2t, and plus minus 4a minus b sine of 2t. And then we multiply 3 to the y prime term. So plus e to the power t, and we're going to multiply 3 to the coefficient. This is going to be a 3a plus 6b cosine of 2t. So I'm going to keep the negative sign here. And then basically next one is plus 3b plus minus 6a sine of 2t, and then minus 4 e to the power t, and then with basically the y term, which is a 4 cosine of 2t, and then plus 4b sine of 2t, and that is equal to minus 8 e to the power t cosine of 2t. Now let's equate the term and same time merge all these terms, which is basically on the left hand side, and then equate it. So as you can see, the cosine term is going to be minus 3a plus 4b minus 3a minus 6b minus 4, that was sorry a, so minus 4a, and this is going to be equal to minus 8 because cosine e to the power t cosine t has coefficient to that. The next one is a minus 4a minus b, then plus minus 3b plus 6a, and then you have in the last one minus 4b, and that term is going to be equal to 0. Let me change the color. I'm going to erase this piece. So let's see, this is a 3, this is a 3, 6, and that is 4. This is a negative 10a, and this is a minus 2b is equal to negative 8. This one is, let's select a term, this and that, which is 2a, and b term we have this, this, and this, so which is 4, negative 8. b is equal to 0. So if I multiply this equation by 5 and add, I will get this 0, and that is a 5, 40, 40, 42, b is equal to negative 8. So b is equal to negative 8 divided by 42, which is a minus 4 divided by 21. And then if I plug that one into the second equation, so I get 2a minus 8 times minus 4 over 21 is equal to 0. Therefore, a is equal to minus 6, minus plus is minus 16 divided by 21. Therefore, if we go back and plug this into our the solution, then we get our solution. Our solutions will be y of t, I'm going to write on the top of the screen, is equal to minus 16. Let's write e to the power t first out, and then minus 16 divided by 21 cosine of 2t, and then minus 4 divided by 21 sine of 2t. There were a lot of calculations, but the process is almost the same, which we have been using in our previous examples. Okay, let's do one more examples where we have the polynomial function and they are multiplied to the exponential function. In this case, the solution will look like this. The assumption of the solution will be of this type: a plus bt plus ct cube, and the exponential stay as it is with this. So first we will begin again calculating the first order derivative. It is a product rule. So first is, let's take the derivative exponential function first and then keep this function as it is. And then we will take the function derivative inside function, which will be b plus, sorry, that is a 2, not 3. That is a 2ct time e raised to power 2t. So when we have exponential, we can pull out e to the power 2t, and then we left with 2a plus 2b plus 2c time t, and then plus 2ct square inside. Now let's do the double derivative by double prime of t. So it's going to be e to the power 2t, and then 2 multiply, I'm going to multiply inside to make my calculation a little bit easier in the next step. And that's a 4b plus 4c time t plus 4ct square. And we take e to the power t as it is, and I'll take the derivative inside the function. This is a 0, so it's going to be a 2b plus 2c, and then 4c time t. Again, e to the power 2t is a common factor, so we will pull that out, and then we range these terms. So we have 4a plus 2b plus 2c, that these are the constant term, and then the term containing t is a 4b plus 8c time t, and the term containing t square is just 4ct square. Now again, very similarly, we are going to plug everything back into the equation. So y double prime, so we have e to the power 2t and 4a plus 2b plus 2c plus 4b plus 8c times t plus 4c t square. And then we have minus 2 times a y prime term. So y prime term is again e to the power 2t and it is a 2a plus 2b plus 2c times t and then plus 2c t square. Then the y term is simply a plus bt plus ct square e to the power 2t also is equal to t square e to the power 2t. Let me clear this calculation on the side. And then we will do is equate the coefficient. We collect all the constant term, the term containing t and term containing t square. So the constant term is coming from this, which is a 4a plus 2b plus 2c. Here the constant term is in 4a and the last constant term is plus a. That is equal to 0 because there is no constant term on the other side, or with the constant term with multiply by e to the power 2t. Let's calculate the term with the containing t, which is a 4b 8c minus 4b minus 4c, and this is a plus b and this is also equal to 0. The term containing t is a 4c. In the second one, the term containing t is also 4c. And the term containing t in the last one is just c. And that is equal to 1. So this gives us c is equal to 1. The last one. Now let's go back to the equation number 2, which is basically b, this cancel out. And then you have c in it, so which is a 4c plus b is equal to 0. So this implies b is equal to minus 4, c is 1. Now let's see this cancel out, and you have the value of the b is 4, so it's negative 8. C is 1, so 2 plus a is equal to 0. Therefore, a is equal to negative 6, so positive 6. Therefore, now we can write down the solution because we have a, b, c. So I'm going to write down the solution again. The top here, y of t is equal to a is a 6, b is negative 4t, and c is just 1, t square e to the power 2t. So this is a particular solution to this example. So again, in all these different forcing term, if you won't be able to find, if you can be able to determine A, B, C, or in other words, if any case fail when you select the form of the solution, all you have to do is you have to multiply by 1 extra t and then redo all the calculations. So every time solution fail, we multiply it by t and continue the process. Okay, this is all for today. This is the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.